Hello everyone, my name is Abins Tiwari, currently studying at grade 9 and I'm here with my team.
My name is Stawan Marsini.
And I am Swonigaw Shrestha.
Today we are here to show you our Catapult statistics project and its findings.
Let's get into how we built our Catapult project.
We built our Catapult project from recycled items like Jenga sticks, paint brushes, rubber bands and other items.
Now we are going to dive into the calculations part.
We will be finding mean, standard deviation, mean deviation and quartile deviation with our Catapult project. Mean discusses the average distance acquired by our catapult, and it also shows the performance.
Secondly, we have mean deviation. Mean deviation gives us an insight onto the overall dispersion of data.
Thirdly, standard deviation. Standard deviation reveals the consistency of the flows of the throws.
Lastly, we have quartile deviation. Quartile deviation tells us about the variability of the data.
Now we will be performing the activity part where my friend Stawan will be launching the projectile with our catapult in a fixed angle, and my friend Abins will be measuring the distance where the projectile has been thrown, and we will repeat this process 20 times. Now Stawan will be launching the projectile. 5 meters. We have repeated this process 20 times, so now we can move on to the calculations part. So this is our calculations part. And as mentioned earlier, we launched the projectile for a total of 20 trials from my catapult. We got 5 meters for 4 times, that's why the frequency is written as 4, and so on and so forth. We know that the formula to find mean is summation fx by n, and we found summation fx and got the mean as 5.7 meters, which is close to 6 meters. Now finding the mean deviation, we had to find the absolute value and multiply it with the frequency and got the mean deviation as 0.47 meters. Moving on to standard deviation. We know that this is the formula to find standard deviation, and after the calculations, we found standard deviation as 0.469 meters, which shows the accuracy and consistency of the performances of our catapult. Now let's move on to interpreting the data.
First, consistency. If the standard deviation and the quartile deviation are low, it means that the catapult is consistent in its throws.
Moving on to accuracy, as we can see that the mean distance is close to the desired value, it shows that our catapult's performance is very accurate.
In conclusion, the catapult's mean distance came out as 5.7 meters with a standard deviation of 0.469 meters, indicating moderate consistency. Overall, the performance of the catapult was reliable but can be refined for better accuracy and precision.
And this activity is the real-life application of statistics.
Please like and subscribe for more videos. Thank you.